In the last video, we spoke a little bit about two-set analysis. In this video, we will do just a few minutes on three-set analysis. The bulk of the time in this video will be spent with me drawing these Venn diagrams, so I apologize for taking a little extra time. So a three-set Venn diagram is just when you have three sets. So in this case, I have A, B, and C. And remember, the universal set is on the outside. So for example, if I wanted set A, I'll write A in green, and then I'll color in set A. Set A is right here. And then let's find set B in blue. Set B is everything in set B. And set C is everything in set C. So now a first question that might be easy to help you understand a three-set Venn diagram is, what would A intersect B intersect CB, or the intersection of all three of them, the intersection of A, B, and C? Well, what is the only region here? And we'll do this in purple. I should have written it in purple. What is the only region here which includes all three of them, which includes the intersection of the three of them? It's this little centerpiece. In a three-set Venn diagram, you have all the combinations. You have A and B without C, you have B and C without A, but you also have this little section which includes all three, A, B, and C. So we'll do a little practice problem here where we do one of these when we're trying to figure out what is A intersect the complement of B union the complement of C, because these can get a little complicated, but as long as you take it one piece at a time, everything works out. So we need to figure out this problem. We have three pieces in the problem, but remember, in math, we always work left to right unless we have parentheses. So first, let's just worry about A intersect B complement. So we need to know what those two pieces are. We know what A is. In fact, I'll rewrite A just for the picture. This is A, and then this will be B complement. So A, and I can use this little drawing pencil. Oh, I can't use this little drawing pencil. Switch back to blue on the marker. A is this right here, these three regions, these four regions. B complement is everything that's not in B. So B complement includes the outside. It includes right here, this C part is not in B, this is not in B, and this is not in B. And so when we want to take the intersection of these, when we want to take the intersection of A and B complement, we want to know what pieces do they have in common. What pieces do these have in common? Well, A, we can only have pieces that are inside of A. We can only possibly have pieces that are inside of A. So we can have these four sections. And if we were to draw these pictures on top of each other, you kind of want to know what would turn out purple. Where the blue and red would overhang. So I'll do it in purple. And it's really just these two sections, this section right here and this section right here. That is A intersect B complement. And now we can take that. This is, maybe I'll move it over a little bit. We can take this, which is A intersect B complement, and then we want to union that with C complement. So let's draw C complement real quick. And these Venn diagrams can be written pretty small in a notebook. It's pretty easy to write one. The opposite of C, or C complement, is going to include this piece, this piece, this piece, everything on the outside of C, so including the outside, the universal set, not including the three pieces. And we're unioning them, which means everything that's colored in both pictures is going to end up in the region that we keep. So we'll draw another picture, and we'll draw the union. And this will be our final answer. So the pieces here are just these two. So we'll fill those in. And then the pieces on the right include the outside, so we'll include the outside, the universal set. And it also includes this little centerpiece, and it includes the inside here. So that is our solution to the question. Let's see if I can remember the question. A intersect B complement unioned with C complement. And that is our final picture. You haven't used yellow, circle it in yellow. And you see, if you work through these piece by piece, just left to right, working through the problem, all it is deciding where to color and which pieces to color. There's not much work to it. So this is 3-set analysis. You'll have a couple problems to solve using 3-set analysis, but as long as you work one step at a time, it should be pretty